Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we are going to be talking about firewalls, an absolutely invaluable tool to have in your infrastructure that also turns out to be a complete pain in the ass, right? Firewalls are actually pretty simple devices, or at least the concept of a firewall is a pretty simple device. Basically, all we're going to be doing with a firewall, more or less, is we are going to be blocking TCP ports, right? So when our computers are communicating, whether they're communicating with a server on our internal network, a printer on our internal network, or going out to the internet and trying to access something out there, they're going to be using the TCP/IP protocol, right? So TCP/IP version 4. IP version 4 is the protocol component that allows you to create IP addresses and subnet masks, have default gateways, all of that kind of thing. TCP, the first part of TCP/IP version 4, is transmission control protocol, and this is the protocol that actually allows computers to create connections with each other and then be able to send data back and forth. Now, one of the ways that TCP allows computers to connect to each other is by having something called TCP ports, right? So when you look at the TCP/IP protocol, think of the IP address as the street number for a building. Let's say you wanted to go to a big office building, and in that office building, you had a printing company, and in that office building, you had a telephone company, and in that office building, you had, I don't know, all kinds of different companies, right? The address for that building would be the IP address, and then after that, you would put colon, and then you would put a suite number. So suite, let's say 80, right? So port 80 is the TCP port used for HTTP. So if you use a web browser and you're trying to access a website on a web server, your computer will go to the IP address of that server and then access port 80. If you try to use something called SSH, Secure Shell, a way to remotely administer a Linux machine, you would connect on port 22. If you're trying to send email services, that would be on port 25, right? So TCP ports are the actual kind of, essentially think of it as a suite number for the server that your clients are going to be connecting to. So if you're trying to secure your server, you're trying to secure your network for whatever reason, one of the easiest ways to do that is simply not allow traffic on certain ports, right? So imagine like with SSH. So SSH, if you do not know what it is, at some point you will. It's, again, another invaluable tool. What this allows you to do is it allows you to remotely connect to Linux servers on your network, right? So if you need to do administrative tasks, change configuration files, do all that kind of stuff on your Linux servers, you would be using SSH in order to do that. Well, here's the question, right? Let's say you want SSH to work on your internal network, but you don't want people from the outside world to be able to SSH into your internal servers. The outside world may be the internet, or the outside world may be simply your WAN, your MAN, your CAN, wide area network, metropolitan area network, your campus area network. You're concerned about hackers possibly being in a different building within your network, and so you want to make sure people from another building in your network are not able to SSH into your servers, trying to do a brute force attack or something like that. One of the things you could do is you could put a firewall on your network and simply not allow traffic on TCP port 22. If somebody tries to access one of your internal servers trying to come over TCP port 22, the door for the network is closed, and therefore no amount of brute force attacks, no amount of whatever else will actually allow somebody to access your internal systems from the outside world. This can be a very, very valuable thing with hackers or, again, nefarious users too, is because sometimes people will be trying to get access to your internal systems from the outside world, and they'll actually have the credentials. Possibly the credentials were hacked, and so they're out there sitting on some kind of dark web website or deep net dark web. I get confused. Anyways, dark net. It's on the dark net, on some kind of onion site out there or whatever. And so somebody's actually able to get the credentials to try to log into your systems, right? So having a firewall that blocks port 22 will stop them from being able to have that connection. Additionally, you may just have a user that, let's say they got laid off. One of the big problems that we have in the real enterprise world is that user accounts are not disabled nearly quick enough. And sometimes they're never disabled because sometimes the person that got laid off was the person to disable user accounts, which is its own mess, right? So one of the problems that you can have is you may have active credentials on your network that a user had, and they were laid off, 3, 4, 5 months ago. They didn't do anything for 1, 2, 3, 4, 5 months because they thought they were going to get a new job. They thought they were going to move on. They still haven't got a new job. Day after day after day, they get more and more pissed off at your company. And all of a sudden, 6 months after they were fired, they're now trying to use active credentials in order to access your internal network and start causing havoc, right? If you have a firewall that prevents SSH or whatever kind of connection from happening, then even with those active credentials, those active usable credentials, they will not be able to get in and to be able to access your networks. If you watch any of my videos, if you take any of my classes on cybersecurity, one of the most important things with cybersecurity is having layers of security, right? It's not simply about good passwords. It's not simply about encryption. It's not simply about firewalls. It's not simply about antivirus. It's not simply about all this other kind of stuff, right? It's all of these layers of security so that when somebody does make a mistake, assume mistakes will happen. You will have multiple layers of security. So even if, again, somebody has active credentials when they shouldn't, they're still not able to access the network and cause a big mess. But anyways, basically the idea with firewalls is simply this is a way to block communication on TCP ports. All services on computers using TCP/IP use TCP ports in order to communicate using certain protocols. Again, SSH is port 22, SMTP email is port 25, FTP is port 21, I think it is. HTTP is port 80, and so that's why firewalls can be very powerful. Okay, so the basic configurations that you're going to deal with when you're dealing with a firewall is you are going to be saying what TCP port in general you want blocked. So port 22 for SSH, port 25 for SMTP, port 80 for HTTP, so on and so forth. And then you're going to say whether you want inbound traffic blocked or if you want outbound traffic blocked. And this is one of the things that people get confused by, and if you do not configure this properly, you can cause yourself a hell of a lot of misery. When we talk about inbound or we talk about outbound, what we're talking about here is where the communication originates from, right? So if you have your network and communication originates from outside your network and tries to go in, then it originated outbound. If it originates inside your network and tries to go out, then it originated going outbound. Why this is important is many times it is as an administrator, you may want to be trying to block certain communication services, maybe like remote desktop services if you're worried about nefarious actors in the outside world being able to remotely control your systems inside, VNC, that type of thing. And one of the issues you have with this is when you say inbound or outbound, this is blocking where the communication originated from, right? So let's say for VNC, I forget the port for VNC, but VNC has a specific port. VNC is basically a remote desktop application. So let's say, you have your firewall, right? You have the internet. You have somebody outside on the internet connected to your router firewall and connected to your internal network and one of your computers on the internal network. So you may go into your firewall and you want to say, I want to block all VNC connections that are coming inbound. And you're thinking, yay, now my network is secure. But here's the thing, hackers have thought of this. Frankly, your employees have thought of this. So one of the interesting things that can happen is somebody can install a VNC server or VNC software onto one of your computers. That VNC software can initiate the communication out to the outside world, and then essentially somebody in the outside world sitting at a terminal can then use that communication and then be able to follow it back to get back to the computer that has VNC on it. And since if you have inbound traffic blocked, inbound originating traffic blocked, this did not originate inbound, this originated going outbound. And then they're able to basically get through your firewall and be able to do what they want on the internal network, right? So that's when you start looking at the whole inbound, outbound thing. You have to be thinking about how do you actually want to be blocking the traffic and why. Again, are you protecting against something like VNC, anything like that. A lot of times when people are thinking about firewalls, they're thinking about those darn Zimbabwean hackers, right? Somebody sitting there in Zimbabwe and they're trying to access your network and do all kinds of stupid stuff. The big thing to realize is that many times the hackers have already gained access to your network in one fashion or another. And so many times you actually have to protect the outside world from you. And that's one of the reasons why you have outbound firewall rules, right? So let's say your network is connected to the cloud, you have your router, you have your firewall, you have your switch, and then you have all of your computers that are connected to the switch. One of the issues that you can have in the real world is that there are basically spam databases with IP addresses that are known to send spam messages, right? And this can be a really big problem because if you have an email server on your internal network and your external IP address gets flagged as an IP address that sends spam out to the world, then basically your IP address can be put on one of these spam databases, and every time you try to send emails or any of your employees try to send emails, invoices, anything like that to your customers, clients, vendors, whatever else, the emails will literally get blocked because your IP address is in a spam database. And then you may be sitting here and like, well, but why would my IP address be in a spam database? My email server, my Exchange server isn't sending spam. Well, one of the curious things that you can have happen is you could have one of your users on your network decide that they're going to go to puppy porn.com, right? They like cute puppies and they cannot lie. So you have somebody on your network, they decide to go out to puppyporn.com. They're looking at all these cute, adorable puppies. And as they're looking at cute, adorable puppies, puppyporn.com is able to actually install an email server onto their client machine. Remember with viruses, when we talk about spyware, malware, viruses, all this is software. It's software just like Word is software. It's software just as antivirus software is software. It's just software. What makes malware and spyware and viruses different than quote-unquote normal software is basically that it's trying to do something that you specifically do not want it to do, right? You install Outlook onto your computer because you want to be able to create invoices. You install Word on your computer because you want to be able to create documents. You don't want your computer to be a spam bot, right? And so basically, if one of the users on your network goes out, and they get an email server essentially installed onto their computer, the problem that you can have is then all of a sudden their computer, my pen is causing me problems right now. Their computer starts sending email out to the outside world with, advertisements for Viagra and advertisements for puppyporn.com and advertisements for all this kind of stuff, right? Basically sending email out, not from your email server, but simply from one of the client machines. And so the problem is then your IP address gets put in these spam databases, and then all of a sudden all of your legitimate legitimate emails just start getting dumped into spam filters or simply blocked entirely, and you can run into a lot of problems. So what you can do, right, is at the firewall, so you have this firewall essentially right here, what you can say is I don't want any port 25. What's going on with my pen today? I don't want any port 25 traffic outbound to be allowed to go out, right? So anything on port 25 that's trying to go out, simply block that. And so then what will happen is the firewall will simply block the traffic on port 25 that's trying to go out, and therefore you don't have to worry about any of the users, any of the other users going to puppyporn.com and getting an email server installed onto their system. Although it's a problem that you have an email server installed onto all these individual systems, the reality is you kind of nullify the problem for you because the firewall will now be blocking port 25 so that the traffic will not go out. Again, this is where we talk about layers. You should have antivirus, you should have permissions, and should have security, you should have all this kind of stuff. But if somehow somebody gets around that by having the firewall be able to block certain ports trying to go outbound, this stops any additional problems from occurring. Now, when we're talking about firewalls, there's generally two types of firewalls that you're going to be dealing with. The first type of firewall is what most people think about, and this is hardware firewall. So a Cisco firewall, a Checkpoint firewall, a SonicWall firewall, a fill-in-the-blank firewall, right? And so basically, with one of these hardware firewalls, generally they are connected to the network and they protect the entire network from any of this type of TCP traffic that you do not want to occur. So you put one hardware firewall on your network, and then within that you have a whole bunch of configurations that say, what ports the communication is allowed on, whether it's incoming or it's outgoing, what IP addresses can communicate or not. That's one setting that you can have in here. So you can say, like, you want your email server to be able to communicate on port 25, but no other computers on your network should be able to send anything out on port 25, the whole 9 yards, right? So that is a hardware firewall, and that's one of the firewalls that you're normally used to dealing with. You can also have, though, a software firewall. And so you have your computer, you have your server or whatever else, and basically as a piece of software on that computer or on that server is you actually have a firewall component. And so at the computer level, you can say what ports you want people to be able to access that computer with or not. So if you have something like a web server, right? So you have a web server, serving up web pages. So you want people to be able to access that web server on port 80. So port 80 is the HTTP port, but you don't want people from the outside world being able to access that server on port SSH, port 22. So one of the things you can do is in the software firewall, you can say that port 80 is good to go. You can get communication in on port 80, but that port 22 SSH, you don't want that to be able to work on your particular computer. This can be very useful for you whenever you're building out your infrastructure, because nowadays firewalls are generally either built into your software or very easy to install on your software. So if you're in the Windows world, you have Windows Firewall. If you're in the Mac world, there's a Mac Firewall, software firewall that's built in. If you're using Debian, you're using Ubuntu, there's something called UFW, I think it's called Uncomplicated Firewall. And so one of the interesting things that you can do here is, again, when you start thinking about layered security, right? Layered security. So what you can do is you can have a hardware firewall, right? And so for the hardware firewall, for communication to the outside world or from the outside world, you can put a whole bunch of rules in here, right? I don't want SSH to occur. So port 22, I don't want that to happen. I only want port 25, outbound. So email services from the Exchange server, right? In the hardware firewall, I can put configurations there on the overall network level. But then once I go into my internal network, there may be some additional security configurations that I want to set up to try to protect my servers. So let's say I do have a web server, right, internally. So the external firewall will allow port 80 inbound to my web server. Now, the web server, let's say it's some kind of a content management system, something like that. So it has a database backend, right? So if you're dealing with, let's say, WordPress or Drupal, you can use MySQL or MariaDB. And with that, you may actually create a cluster, right? So let's say you create a cluster of database servers so that if any one database server fails, you still continue to have database services for your network. So what you can do here is using UFW, if you have Ubuntu installed onto these database servers, is you can create firewall rules that basically say these servers can only communicate with other specific servers on specific ports, right? So let's say this is 192.168.1.2, and this is .3, and this is .4, and this is .5. Let's say the web server is 192.168.1. Let's say 11, something like that. So what I can do is I can create a rule for these database servers, and what that rule will be is it'll say, okay, I want my MySQL servers, .2, .3, .5, .4, within their software, within the UFW software firewall, I only want them to communicate with 192.168.1.1 on whatever port MySQL uses for the connection, right? So basically, inside my web server, I have Apache, I have WordPress installed, the backend uses MySQL, so I find out what port MySQL uses, and then what I do is I say for these particular computers, I only want them to be able to be accessed on the database port by this particular server. This is a valuable thing because, again, let's say a hacker is able to get into your network and they realize that you have this database cluster, and so they start trying to do brute force attacks, or they try to connect to this database cluster in some way to be able to compromise it. If you have a software firewall configured onto all of these servers that say MySQL can only be accessed by this one particular server, then even if somebody is able to get into your internal network and start trying to connect to the cluster, they won't be able to do it because every time they try to connect on TCP port, the TCP port, whatever it is for MySQL, the servers that they're trying to connect to will simply say, nope, you are not the appropriate server, so we will not allow that to happen. And so that's one of the cool things with software firewalls. It allows you to go to each and every individual computer, each and every individual server, and say, okay, specifically, what kind of communications do I want this server to be able to have, period, and then go there and start tweaking and figuring out, what the rule should be. It might be like with the web server, right? So let's say you have a web server, and on that web server you do want to be able to remotely administer it with SSH. So again, that is port 22. One of the things you could do is within the firewall in that web server, you can go and you can put a static IP address for your computer, right? So you have your own little desktop or your own little laptop computer, and its IP address is like 192.168.1.15. So what you could say is, I want to allow port 22 traffic on 192.168.1.15 inbound, and I want to block all other SSH traffic. This is a way to allow you to be able to remotely control your computer, remotely administer it with SSH, but also prevent the SSH from being open up to the entire network and the rest of the world, right? And so that's what software firewalls allow you to do, and it's one of the things that makes firewalls very, very, very powerful. So when you have a hardware firewall, the hardware firewall firewall is essentially going to protect the entire LAN. Everything that is connected to the switch, the LAN, will be protected for the hardware firewall. So there you have the bare minimum number of rules because you don't want to create problems, right? First thing as a technology professional is don't make things worse. So there you have the bare number of rules, and then inside for each one of your servers, you then figure out exactly how you want that server to communicate, and with the software firewall, you then create the specific rules there. So one of the next things to look at when you're dealing with modern firewalls is we have what are called network firewalls and application firewalls, right? Because again, we are now in the 2020s, and simply trying to configure very specific ports seems like an old school thing. That's what you would do in 2005, not in 2025. Sitting here and trying to figure out each individual specific port can legitimately be a complete and utter pain in the ass. So whenever you're dealing with a network firewall, what that means is you're specifically stating what ports are or are not allowed. 21, 22, 80, 443, whatever else. The next type of firewall that you can have, and you might be actually a little bit more used to this in the modern world, is something called an application firewall. This makes life a hell of a lot easier. Essentially, with an application firewall, what you can do is you can go to the firewall and you can say, I want Skype to be able to work. Right? Skype is good. Google Hangout is bad. And basically with application firewalls, they understand how specific applications communicate. And then because they understand how specific applications can communicate, it can be a lot easier to manage than trying to figure out exact port numbers. Again, in the modern world, when you deal with advanced software that uses network communication, many times there can be multiple protocols that are being used. So if you're trying to shut down communication, or you're trying to verify that communication is working properly, one of the issues may be is you don't know all the individual ports and you're screwing up because you simply forgot one port to allow or to block. So if you go in and you say, hey, again, I want Skype to work, an application firewall knows how Skype communicates with other computers, and so it will allow the Skype communication to occur. This can be very valuable for you in the enterprise world, where the reality is many times executives should be able to have access to software that not everybody else should. Shh. Don't tell the cogs this. Don't tell the employees this. But being an executive has privileges that sometimes being the secretary or the warehouse worker don't have, right? So you may have this with things like maybe some kind of media player, something like that, like iTunes. Like it may sound like a joke, but like your marketing department, you may need people in your marketing department to be able to download and watch videos from iTunes when you do not want your secretaries downloading and watching videos from iTunes. So in an application type firewall, what you could do is you could find the IP addresses for your marketing department, maybe the subnet or whatever else, and you can say, okay, I want iTunes to be able to work, to be able to function on 192.168.1.55 or whatever else, right? You may have specific computers, and you say, I want these specific computers to allow iTunes to occur. This may also be true with things like Twitch or things like YouTube. Again, you have a marketing department. So do you want everybody in your company to be able to live stream from the company network? No, hell no. No. I do not want my warehouse workers live streaming, literally using the company network in order to do that. That's a liability that I don't want to get anywhere near. On the other hand, legitimately, your marketing department or your sales department may have need of using live stream, some of that kind of software. And so basically with the application filter, what you can simply do is you can say, okay, I want to allow this specific piece of software to be able to use either on a specific IP address, possibly a host name. With some of these firewalls, you can plug in the host name instead, which makes life a lot easier, possibly a subnet mask, something like that. And so that's why this type of thing can be valuable. So a network firewall blocks specific TCP ports, blocks or allows TCP ports. The application firewall basically understands how an application works on the whole, and then will allow or block an application based off of the, what configurations you put in there. Again, to be clear, this is a network application, so Skype, VNC, again, live streaming, that type of thing. This is not Word. You do not block Word using an application firewall. Firewalls are specifically about network communication. So now we understand basically what a firewall does. We understand hardware and software firewalls, and we understand network and application firewalls. The final thing to really look at is the overall classes of firewalls, right? So you may have heard of an SPI firewall. This is a stateful packet inspection firewall. You may have heard of a UTM firewall, and you may have heard of an NGFW firewall. And these are overall classes of firewall. SPI is the simplest type of firewall. NGFW is the most sophisticated type of firewall. So what an SPI firewall is this is called a stateful packet inspection firewall, right? So this became a necessary thing once we started using NAT. So NAT is network address translation, and so this is where you have a router on your network. You have an external IP address for that router, 252.66.22.1, and then inside you have a whole bunch of client machines on the 192.168.1.x subnet. And when they go out to talk to CNN.com or to watch a YouTube video or whatever else, they're using the external IP address to connect to the external site or service that they're trying to communicate with. And then the firewall with NAT on it knows who's communicating to the outside world. And so when the communication comes back to that router with network address translation, then the traffic is simply routed to the appropriate client within the network. One of the issues you can run into with this is, especially with hackers and nefarious actors, is basically what they can try to do is they can try to say, okay, well, since we know this communication is going on, can we piggyback basically some kind of communication and try to get to the internal network based off of the communication that's already occurring. So you're trying to go to CNN.com, and evil guy, .com tries to get in on this network communication and start sending its own packets to your computer, trying to get them to get put back together and basically install a virus or malware or spyware onto your computer. What SPI does, stateful packet inspection, is it looks at the actual communication stream and it makes sure that all the packets that are coming back in, going out, or coming back in are related to that specific communication that is going on, and anybody that tries to essentially try to piggyback onto that communication, their traffic is blocked, right? So SPI really became a valuable thing, with NAT, network address translation, because you start to have multiple computers on that internal network. You have a firewall with all these different rules, and so essentially nefarious actors were trying to get around that firewall by figuring out how you were communicating with outside services, and then again, essentially trying to piggyback with the communication to get in. Stateful packet inspection goes, okay, 192.168.1.15 is communicating with CNN.com. All the CNN.com packets go back to .15, but when evilguy.com tries to also send a couple additional packets in, it's like, oh, wait a minute, that's not communication that's supposed to be occurring, so those packets get dropped. Pretty simple thing. Past that, then we get to UTM firewalls, which are actually pretty nifty, neat, and cool. These are unified threat management firewalls. So, right, people started thinking, smart people started thinking, hey, we have this piece of networking equipment that essentially all communication traffic is going through on our network. I wonder if we can value add services to this firewall to provide additional services and make it so we can charge a hell of a lot more money, right? Come on, it's the 2020s. You can't charge very much money for simply blocking TCP ports anymore. And so with unified threat management, the thought was, what if we put antivirus directly into the firewall? So I first saw this with Barracuda. I think they're still around. Barracuda used to actually make antivirus firewalls. And so basically you have this firewall, all the packets are going through the firewall. And so the firewall is actually able to read all of the packets going through, and it's able to understand what the files going through are. Oh, this is an email, this is a video file, whatever else. So just like the antivirus software on your computer can detect a virus based off of, signatures or whatever else, what they realize is, hey, we can actually have an antivirus firewall that is able to see viruses as they're coming into the network and then just stop the virus there, right? So you go to CNN.com and a hacker is able to maliciously, put a virus into an advertisement or something on CNN.com. This is something that really happens, right? So you go to CNN.com, but when you go to CNN.com, there's a lot of embedded crap on CNN.com. A hacker is able to essentially embed a virus onto CNN.com. So when you go there, then the virus gets sent back to you, and normally your computer that would then open it up or execute it or whatever. You can have a UTM antivirus firewall. When the virus hits the firewall goes, oh, this is a virus, and you literally stop it at the firewall level. Again, if you are in the enterprise world and you are not using an antivirus firewall, you really, 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 really should think about it, right? Stop the virus before it even gets into your network. That can be a very useful thing. Beyond antivirus firewalls, you can have actually anti-spam firewalls. Again, the firewall is able to see, oh, this file is an email, and then it's able to read the email if the email is not encrypted, and based off of the information in the email, it can say, oh, this is coming from puppyporn.com. We're not even going to let that to go into our internal network. So basically, with this unified threat management firewall, it adds a whole bunch of additional services. That's just frankly awesome. Yes, it costs more money. It costs more money because they're really cool. Past that, then you get the NGFW. So what NGFWs are next generation firewalls. These are very valuable because they are designed not simply to be good for today, but also to be good for tomorrow and maybe for the next 10 years, right? One of the issues you have with an SPI firewall is it does exactly what it does, right? Network application firewall, it allows or blocks specific ports or applications. Again, it's statefully inspecting all the packets that go through. But basically, when you buy it, that's what you got. That's all it does. Again, even with the unified threat management firewall, very, very, very cool. But again, also basically has a shelf life of eggs, right? Just like you have to refresh your computers, you have to refresh your servers, software, that type of thing. The reality is that a UTM firewall does what it does and probably does it really well. But when the next cool thing, the next cool technology comes out in 3 days, 3 days after you drop 10 grand on one of these things, it's not going to deal with that because it's not built for that. Next generation firewalls are actually built to be, it's the technology world, so at least semi-future proofed. So basically, they have the standard technologies in there, such as the SPI firewall, like we said before. They generally have integrated intrusion detection. So the idea is when somebody is trying to get into your network or has gotten into your network, that should actually be detected. Has application awareness and control to see risky type apps. This is one of the big things because like generally like with a UTM firewall, especially with the SPI firewall, they're not that smart. They're just not that smart. They do what they're supposed to do very well, but they don't have a lot of brains. If a nefarious actor comes up with a cool new way to try to hack your network, if there's not a rule set for those other types of firewalls, then the hacker may be able to get through it. With the next generation firewall, the idea is that it should be able to detect nefarious activity and then be able to try to learn what problems may be and be able to block that traffic, even if it hasn't initially been taught that that would be bad traffic. The other type of thing that it has in there is that it should actually be upgradable. So just like your server can be upgraded from server 2008 to server 2012 to server 2019, the whole 9 yards, just like your antivirus software can be upgraded with a next generation firewall, the idea is that you should be able to upgrade this firewall that you have. Think about it as essentially having an operating system on this firewall, and just like you upgrade the operating system on your Mac every once in a while, that you can actually upgrade the operating system on a next generation firewall in order to keep it up to date with whatever the new protections that you need to have is. And then finally, the idea with these next generation firewalls is that they should be designed with the concept that when new security techniques come out, you should be able to implement those new security techniques within a next generation firewall. So when they come out with the next type of intrusion detection or antivirus protection or anti-malware, right? Because again, every month, every year, they're coming up with new ideas on how to make things more secure. So the idea with the next generation firewall is it should be built with kind of that, again, that upgradability in mind. Even if a security service has not yet been created, the idea is that when it is created, you should be able to, pay a couple of bucks. It's not going to be free, but you can pay a couple of bucks for the license and you'll actually be able to add that to a next generation firewall. And so this is one of the things you need to be thinking about when you look at your enterprise, when you look at your organization, and when you're going out there to buy products, right? A stateful packet inspection firewall is going to cost you nothing, right? I mean, maybe if you buy a Cisco one, it'll cost you $1,000. But if you go out there and you buy a stateful packet inspection firewall, hardware firewall for network from 100 to 500 people, you're going to spend probably a couple of $100 on it. And it's going to do a very basic what you think a firewall does, right? You go for a UTM firewall, you're probably going to spend about $1,000 on the firewall, and then you're going to pay for client access licenses. That's the bugger with the unified threat management, is basically you say how many clients you have on the network, and then it's $5 or $50 or whatever else, essentially, for each device that you're trying to protect, right? Again, but you have to give this to your executives to decide what the real value is. You go up to a next generation firewall, this thing might cost you $10,000, but this is a piece of networking equipment that should last you for a significant amount of time. And if somebody comes out with a fancy new toy a couple of months from now, this should be upgradable. This again is where I talk about, as a technology professional, it's as much art as it is science, right? The science is SPI, NTM, UTM, or NGFW. The art is figuring out what your particular enterprise needs and goes from there. Like if you're creating, let's say you're looking at two offices that are approximately the same size, right? So let's say you have one client and their facility is an auto repair facility, like Ford or Toyota or Tesla, whatever else, right? Let's say it's a fairly large dealership. So at that dealership, they have 50 users. So you have 50 users, 50 computers, a whole bunch of mobile devices. viruses, the whole nine yards. So you sit there and you take a look at that particular threat assessment, and you may say, okay, well, I don't believe that they're storing very private information on their network. Let's say for this particular dealership or whatever, they're not dealing with the credit card stuff. Let's say the credit card and all that's on an entirely different network. So they're dealing with, they have the VIN number for the vehicle, they have a parts list, an inventory list, that type of thing. Okay, so I do know I need a firewall on this particular network, but these people are cheap anyway. You know, an SPI firewall is probably going to work. They have a lot of very low-end, crappy computers. Even if they wanted to go to puppyporn.com, they probably don't have enough hardware resources to be able to see anything if they went there. So for this particular environment, we're going to use a $200 SPI firewall, right? That probably makes a lot of sense. On the other hand, if you're dealing with a law firm, right? So you have a law firm with 50 partners or 50 employees. You're dealing with a lot of personal information. You're dealing with a lot of proprietary information, trademark, privacy, the whole nine yards. Then, right, it might actually make sense to buy one of these NGFW firewalls because you should be able to do a hell of a lot more protection for the network. It'll be upgradable in the long term. And so even though this thing might cost $10,000, versus $200 for a legal environment, that may make a hell of a lot more sense. And so this is one of those things where I need you as a professional to really be thinking about what your client needs. It's not about what your budget is. I don't care how much money you have in the bank. It's not about what you think. It's about what the organization or the company really needs. I think about this with one of my buddies who lost an incredible client. And so basically, he went out and he installed this network for a small business. It was for a law firm, and he installed the network and the servers and all that. It wasn't that long ago, and it was about $20,000. So his profit on it was about $10,000 for a couple of days worth of work. It was good money. It was good money, right? So, anyways, he installed the new server. He installed a couple of other things for a good chunk of money. The interesting thing was, about 3 months later, the server failed. The server failed. Right? As it does. You install a server, sometimes the power supply fails. Anyways, the interesting thing, so my buddy goes there, takes a look at it. It's under warranty, and so it's from Dell or somebody else, and so it's going to take a couple of days for Dell to send the particular power supply. Now, as he's sitting there and he's talking to the head legal person, the head lawyer at this law firm, one of the things he just lets slip out is he says, because the lawyer is like, why the hell did this just happen? We paid you a lot of money to install this new network. Why has it failed already? And my friend wasn't really thinking about it. And he's like, well, if you had high availability, something called high availability, then if your server had failed, everything would have failed over the server that was still running, and your systems would stay up and running, right? So basically, with high availability, you essentially have two or more duplicate servers. They're connected with a network cable that's it's called a heartbeat. So basically, they keep telling each other which one is alive. With the network, what happens is all of your users are connected to the primary server. The primary server is then constantly replicating any changes to the backup server. And then what happens is essentially with the backup server is continuously listening for the heartbeat signal from the first server. If that heartbeat signal is no longer detected by the second server automatically promotes itself to be in the primary role, and then all of the users on the network simply go over to that new server that was the backup. And literally, this is so fast with high availability. It can be so fast that the users don't even realize it happened. In low quality high availability, it can all occur within 45 to 60 seconds. With some of the faster stuff out there, it can just basically happen in the blink of the eye. As soon as the primary server fails for some reason, the secondary server is up and running. You do not lose your Active Directory. You do not lose email services. The users see absolutely zero downtime, right? And so it's great. For $10,000 extra, that's great. And so the lawyer really wanted to know why the hell they hadn't purchased high availability. And my friend said, "Oh, well, I thought $10,000 would be too expensive for you." And then my friend was fired. Then my friend was fired because the lawyer did not give a crap about $10,000. Here's the thing, there are people in this world that make a lot of money. I had a lawyer at one point that charged $1,000 an hour. An hour. Thankfully, I got a special discount because I don't think I could have afforded that one. Anyway, so when you're dealing with a law firm where each partner can charge $1,000 or more per hour, $10,000 for a next generation firewall is not something that they'll sneeze at. So this is an important thing from the real world to be looking at, is when you're looking at all these different firewalls, when you're looking at the client licenses for the UTM firewalls, when you're looking at the high expense for the next generation firewalls, one of the things to really be thinking about is what is the bank account of your client, not of you. What are their expectations? And then building out an infrastructure based off of that. Okay, so the final type of firewall that we have to talk about are virtual firewalls. And unfortunately, these are the types of firewalls that people kind of sort of forget that they need to worry about sometimes, right? In this modern world, everybody says, just put it on the cloud. We're going to put all of our infrastructure up on the cloud. And a lot of people don't realize, you can put it up on the cloud. When you put it up on the cloud, physically, you no longer have to worry about your servers and your networking equipment and all that kind of stuff. But logically, you do. One of the weird issues with the modern cloud and what is called infrastructure as a service, something called IaaS, is that infrastructure as a service essentially logically mirrors the physical infrastructure that you build. They just simply do it in a virtual way. So with infrastructure as a service, you have VPSs. VPSs are virtual private servers. Essentially, right, you have your cloud and then you create a server. On that server, you install an operating system. On that server, you install, UFW, firewall service or whatever else. On that server, you install the software, all of those types of things, right? With a virtual private server, you may create a database cluster within the cloud where you have all of these instances of database servers. They're then replicating to each other, and logically it looks more or less identical to how if you had a rack of 1U servers, how they would all be communicating. And so one of the things that gets left out when people are building out their virtual infrastructure is they don't think about things like firewalls. They don't think about the virtual networking equipment. So just like you can virtualize a server, you can virtualize your networking equipment. You can have virtual routers, you can have virtual firewalls, you can have all kinds of virtual networking equipment. And so one of the important things to be thinking about is when you build out your infrastructure, thinking about how you can use these virtual firewalls in order to protect your infrastructure more robustly when it goes up to the cloud. One of the big things whenever you're designing infrastructure is you are going to be limited by your budget. Right? So realistically, if we all had an unlimited budget, if IT people had an unlimited budget, we could hire as many technicians as we wanted, and we could drop as much on hardware as we wanted, then essentially every single desktop computer would have a hardware firewall in front of it. You would have a wire that comes from the switch to a hardware firewall that would then go to your desktop computer. Right? Because that's one of the things that would make your computer, much more secure, is instead of even worrying about the software firewall on it, that you actually have a hardware firewall that all of your computers are connected to. Obviously, that would be ridiculously expensive, and so nobody does it. That's why we have software firewalls. But one of the issues that you run into is a lot of times the mentality we use to build out infrastructure is based off of our lived experience, right? Me as an old timer, I remember when servers were very, very, very expensive, right? $10,000 per server. So one of the problems that I can run into mentally is I can design my virtual infrastructure based off of the biases I have from building infrastructure 15 or 20 years ago. When a server costs $10,000, then by God, that server is going to do everything. Again, one of the big security problems, especially with Windows servers back in the day, is you would have one Windows server and it would do Active Directory, and it would do file sharing, and it would do VPN services, and it would do printer services, and it would host a website, and it would have your database on it, right? Because a server costs 10 grand. I don't have a lot of money for servers. And so, right, that was just a disaster because literally your VPN server also is connected to your web server, which is also connected to your Active Directory server, right? Now you can virtualize things. Nowadays, it makes much more sense to create an instance, right? An instance of an Active Directory server, an instance of the routing and remote access server, an instance of your web server, an instance of your SharePoint server, or whatever else. Within that instance, I then close off the firewalls, do its own security, do its own configurations, the whole 9 yards. And the idea there is that if you are able to compromise, let's say my web server, the web server is logically separated from my Active Directory server. So again, when we talk about that layered security, even if you're able to compromise my web server services, you shouldn't be able to get to Active Directory, which compromises damn near the entire network, right? And so that's one of the things to be thinking about again in this modern world when the actual price of servers and services is so small. How can you then start separating things out more and more to provide better services? And that's something to be thinking about in the virtual world, right? When you start going to the virtual world, whether you're using AWS, whether you're using Azure, whether you're using Hyper-V or VMware or whatever else, they generally have virtual networking equipment. And so one of the things to be thinking about is like, okay, now that it doesn't cost me a couple of $1,000s for a firewall to protect a cluster because it's simply just a little virtual appliance that I spin up. Okay, I'm going to put a virtual firewall between my database cluster and my web server cluster, right? So I have a cluster of web servers that provide the website to people trying to gain access to my services, right? So I'm going to put a virtual firewall between this cluster, this database cluster, and this web cluster, so that only communications on very specific ports to this particular cluster are able to happen, right? And to think about like, okay, well, I only want traffic coming in from the outside world at port 80, so I'm going to put, again, another virtual firewall between the actual internet connection and my web servers. So only port 80 communication from the outside world is able to get into my web servers. Only port communication, let's say port 99, is able to go from my web servers to my database servers. And that's a way to start really creating more and more layers. And it's one of those things to be thinking about when you go to the virtual world. Again, it's a whole kind of new way of thinking about designing infrastructure. And so one of the most important things you need to be thinking about as a technology professional is if you are still building your infrastructure more or less like you would have 10 years ago, then you're doing it wrong. If you are not modifying how you build your infrastructure every 5 years, then you're most likely building new infrastructure with baked in old biases that can just add a lot of security and vulnerabilities. So there you go. There was the class on firewalls. Essentially what firewalls do is they block specific TCP ports. Port 22 for SSH, port 25 for SMTP, port 80, whatever else. There's a metric crap ton of ports out there. Go Google search what application you're using and what port needs to be protected. Again, the basic idea with a firewall is if you protect a port, from outbound traffic, that is traffic that originates outbound, that then comes in. If you protect from inbound originating traffic, that is a communication that starts from inside your network and tries to go out. Just do realize, though, that communication can be initiated from one side, and then a computer on the other side then can use that communication to get inside your network. Again, a classic example of this is VNC. So VNC is a remote desktop application type thing. So if you have an internal computer that initiates a communication session to the outside world, and you have the VNC port blocked for outbound, so for inbound connection, the issue can be is, okay, but the connection was created from the inside. Therefore, when it connects with a server on the outside, the person on the server that it connected to, they're now able to access your internal system, and they could try to do nefarious things. So sitting there and figuring out the ports and the inbound and the outbound is a very significant deal. Again, when you're looking at it, there are the hardware and the software firewalls. The hardware firewall is going to protect your entire LAN, essentially everything connected to the switch. That hardware firewall is going to be able to protect. Again, the good point about that and the bad point about that is, the good point is that's one place where you can block a whole bunch of ports. The issue that you can run into is if you block a port that one of the computers inside your network needs, you may run into some issues. So one of the things that you can do is you create very broad rules. You create broad rules in the hardware firewall, and then on each specific computer and server, you create far more specific rules. That's one of the ways, again, that you can create the layers there. Past that, you have the stateful packet inspection firewall, essentially basically just a basic firewall, right? Make sure that the computers that are communicating with each other are the ones that are supposed to be communicating with each other. They have the unified threat management firewalls, which are absolutely awesome. Again, I think about Barracuda firewalls. I guess SonicWall has these kind of firewalls. Everybody has these kind of firewalls anymore. But this is where you can add antivirus services, anti-spam services, all kinds of services you can add to a UTM firewall, and they're absolutely great. But again, just to be clear, it's going to cost you per computer on your network. So you've just got to budget for that. Finally, you have the next generation firewalls. The main thing to think about with the next generation firewalls is the idea is that this is more of like a computer versus something that you're going to entirely replace. The idea here is that you're going to be able to upgrade the software on that next generation firewall. The idea is that it's going to be able to integrate with other components within your security, the layers of security that you have. The idea is that it's actually built. Again, everything has to be designed by somebody. It has to be engineered with a mentality. So one of the mentalities for next generation firewalls is that the person who designed it knows that in 3 days there may be a different threat that they never thought about. And so the next generation firewall should be able to be modifiable so that it can deal with new threats that were not thought about when you initially purchased it. Again, for all that's going to end up costing you a lot of money. But again, it depends on what you're dealing with. A law firm should probably get a next generation firewall. Again, an auto dealership should probably get an SPI firewall. It's really about, again, the budget and the mentality of your specific client. Finally, again, I did talk about the whole virtual firewalls. So when you go in the virtual world, Azure, AWS, whoever else, right? One of the things is you're going to have virtual appliances. So you have virtual routers, you have virtual firewalls, all kinds of virtual networking equipment there. And so one of the things to be thinking about is when you logically design your cloud infrastructure, why not throw in a couple of extra firewalls? Again, a firewall is no longer costing you $10,000 a piece. A firewall is no longer costing you $200 a piece. A firewall is more or less free, or if anything else, is pennies. So why not have a firewall protect all of your clusters? You have an Active Directory cluster. Put a firewall between that Active Directory cluster and the rest of your virtualized network. You have a database cluster, put a firewall in between the database cluster and the rest of your virtual network. Again, that provides a very robust form of network security. And again, in the virtual world, it's going to cost you peanuts. Do realize this is a big problem in the technology profession. And I see it, right? Remember, I started doing technology in 1996. I'm not a young chick. I am not a youngin' in this field. I see it because I see what my own friends do. I see people that I like and sort of respect, and I see what they do. And many times what is horrifying in the technology world is that people learned something 15 years ago and they keep basically building crap based off of the ideology and biases they had 15 years ago. And it's like technology changes, right? So when you're designing your infrastructure, if you're designing it based off of your biases from 2010, that is a bad, 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 bad thing. So just one of those things to keep in mind. Now, in the introduction, I did say that firewalls could be a complete pain in the ass. And so you're probably sitting here and you're going, well, this doesn't sound too bad. SPI, UTM, all this stuff. What's such a pain in the ass about firewalls? Documentation. Documentation. Yeah, it's the word that freezes every geek's heart. No geek likes documentation. The big thing to understand about firewalls is firewalls are dirt simple. They're a very inexpensive, relatively simple way to provide a tremendous amount of protection for your network. The issue is they do exactly what you configure them to do. Exactly. And so in order to make a firewall give your network the most amount of protection, you actually need to audit your entire network, verify what all of your servers are doing, verify what all the client computers are doing, not what users say they're doing, but what they're actually doing. Because that can be a big problem. Like one of the big problems you can have is it's not about users going to puppyporn.com many times or facebook.com or something like that. Many times users are breaking the rules in order to accomplish their job, right? Like I have zero issue of shutting the door on Facebook or whatever. Again, it's horrifying. It's horrifying. I talk about this to employees, and they lose their minds. They literally think they have a God-given right to be able to go on Facebook when the company is literally paying them an hourly wage. I'm getting paid $25 an hour, and I'm checking my Facebook posts. Anyways, I have zero compunction about just shutting that crap off. But one of the problems you run into many times is there are rules that are created by the company, for legal purposes, for regulatory purposes, that type of thing. But many times the company doesn't actually solve the problems the employees are running into. So the employees need a way to share files. So this is a classic thing from the old days. A lot of times we had quotas on, like, let's say our emails, right? So emails couldn't be any larger than, let's say, 10 megs in size. Well, the problem you have is you have the marketing department. They start taking all these pictures, like with raw files or whatever else, and they're 100 megs, 200 megs in size. And so the problem is the quota on the email service is too small to allow them to email the files. We don't have another way for them to share files, and so they start using Google Drive or Dropbox or some services called shadow IT. Essentially, shadow IT is any information technology infrastructure that the IT department doesn't know about, which is a lot in the modern world, a lot. And so one of the problems you can have is they are using this to do their job. They're not screwing around, they're doing their job. You come in, you start slapping in firewalls, you start slapping in security policies. All of a sudden, they get shut off of a tool that they need to do their job. And then it gets bad, right? So one of the things that I talk about, if you ever watch my videos, a lot of my I do like a lot of philosophical videos sometimes. And one of the things I talk about is creating relationships, like learning employees' dogs' names, learning what employees' kids are doing, their hobbies, that type of thing. One of the reasons I talk about that is so that you can create a rapport, you can create, friendship, associateship or whatever with other employees, so that you can go up to them and you can say, hey, look, I'm not your boss. To be clear, I'm not the HR department. I just need to know how you're actually using your computer. And then if they like you and they trust you, then they'll tell you how they're actually using your computer. And then you can design a security infrastructure based off of that. not based off of your imagination. And so that's an important thing, and that's one of the things we run into in the IT world is a lot of IT professionals don't want to talk to users. A lot of it, I mean, when I sit there and I say you should learn the dog's name of the secretary's dog's name, you will see a lot of IT people get really huffy. What they don't understand is that is part of our job. I know the name of the dog that the secretary has so that I can say, hey, that looks like a pretty big file you're dealing with. How do you get that file anyway? That's why the dog's name is important. And so the issue you can run into with firewalls is, again, this can many times be a very blunt tool that's very useful, except when it starts causing a lot of problems. So that's why you have to go through audit. You have to document what's actually going on with your network. You have to talk with your users. You have to talk with all the stakeholders so that you really understand how everything works. And then from there, start implementing your security. So anyways, there you go. There's some firewall information for you. As always, I enjoyed teaching this particular class and look forward to seeing the next one.